Alright, let's do the risk worksheet number 2, Mark betting heavily on college football. If he's got 4-to-1 odds, then whatever wealth he's starting at, I'll call that W0. He has a shot to go up to W0 plus 100 grand. Or to lose 25 grand, which is the original bet. Therefore, the expected value is 20% times the wealth if he wins, and 80% times the wealth if he loses. And if you simplify that math, W0 comes out as 80% plus 20%, so it's 100% W0, and you expect, therefore, to remain at W0, because the 20,000s cancel out. Therefore, it's a fair bet. His expected utility is 20% times the utility of the wealth if he wins, and 80% times the utility of the wealth if he loses. The expected utility of not taking the lottery is simply 100% times utility of the wealth he has, which is equal to U of W0. Part D says true or false if he's indifferent between taking the lottery and not taking the lottery. So that statement, the indifference means that this expected utility is the same as this for Mark. So we can set that up as a mathematical statement as follows. Now the question is this true for a risk-averse person, for a risk-neutral person, or for a risk-loving person? So can we draw a graph for one of those individuals and make this statement true? So let's try a risk-averse person. Okay, so I drew a generic risk-averse utility function. I can draw the wealth, the two states of nature on the x-axis. So if he loses, he has this wealth, which is W0 minus 25,000, and if he wins, he has this wealth, which is W0 plus 100,000. We know the expected value is equal to W0, and W0 is closer to the other side, so that's W0. To find the expected utility of that gamble, which is this right-hand side term, then we draw lines the expected utility, therefore, is where the vertical line from the expected value hits that chord, and so that's the expected utility. That's the value of the right-hand side of the equation here. And clearly, as you can see, the left-hand side, U of W0, has a higher utility. It's given by the height of the utility function at W0. And so this mathematical statement is not true for anybody that has a concave down function. And so it must be the case that the person has a constant margin utility of income. Only when you have a constant margin utility of income, like so, can you get the equation did work. So if you draw the two gambles again, here and here, draw the chord between them. The chord between them is going to exactly overlie the utility function. Therefore, the expected utility is where the chord intersects the expected value vertical line. So there's my expected utility. So that's my right-hand side value. That's this thing. And the left-hand side, utility of W0, where clearly the utility of W0 is the height of the utility function at W0. So it's the same height. So in that case, left-hand side equals right-hand side. So yes, someone who has a constant margin utility of income, in other words, it's a straight line, will behave like Mark did.